All right, folks, welcome to the session. And what we'll be covering today is obviously permutations, combinations, and a bunch of like string-based questions. If you have not had a chance to look at the questions yet, please make sure that you go to the blog. And there is a link to the Etherpad, a link to the blog. It's the usual stuff. If it is your first time and you haven't connected in this forum before, don't be shy. Feel free to ask. Feel free to chat. Ask us any questions. We got a bunch of volunteers who will be helping you with whatever you need, whether it's tech or otherwise. Okay. So moving on to the very first question that we have. I didn't number it this time. I regret doing not numbering them, but what I'm trying to do is the first one is permutations. So do folks know what permutation is?
Yes.
Okay. What is a permutation? Go ahead.
It is a unique arrangement of characters or symbols without repeating characters. So we have with replacement, without replacement. So for example, you have 1, 2, 3. Your permutations would be 1, 2, 3, 2, 3, 1. It's order dependent. And so 1, 2, 3, 2, 3, 1, 3, 2, 1. I don't think I even have them all yet.
I have it on the Etherpad, lines 19, 20, and 21.
Yeah. So
what are the other permutations?
I'm still thinking. So. Sorry. So 1, 2, 3, 2, 3, 1, 2, 3, 2, 3, 1, 3, 2, 1. 2, 1, 3 is another one.
This is provided by freeconferencecall.com.
Go on.
1, 3, 2.
Yep, 1, 3, 2.
Go ahead, type it in. On the Etherpad. Yep, there you go.
2, 1, 3. And 3, 1, 2.
2, 1, 3 and 3, 1, 2. Okay, so is that it? 1, 2, 3, 4, 5, 6. How many permutations would be there?
Pardon?
How many permutations? Given 3 letters, 3, 1, 2, 3 as letters, how many permutations do you expect to see?
3 factorial.
8.
8, is it? Why would it be 8?
So, sorry, there's actually as many permutations as there are the number to the factorial.
So if it's n, then you're saying it's n factorial. Why factorial?
Because for the first one you have 3. For the second, for the first one, if you had 3 options, you would have 3 options for the first one. You'd have 2 options for the second one, and then you'd have 1 option for the last one.
Absolutely, and that's pretty much it. The way the permutations is essentially it is order dependent, so which means that 2 permutations may contain the same set of symbols. So permutations is usually defined with 2 parameters: n, which represents the number of symbols, and r, which represents the number of symbols that you want to select in the final output. So you could have essentially an NCR, the permutation or NPR, which is to say that I say you're given digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I would like to give me permutations of 2 each, just 2 letters or 2 digits. How would you do that? Basically, what you said, Sarlin. I hope I didn't butcher your name. It would be that you.
That's absolutely right.
All right, so thank you. You would pick the first letter, first number essentially.
Oh, you did pretty well.
All right, and then after you pick the first one, so you've decided that the first one's 0, right? What are the possible options for the second one?
Any of the others.
Any of the others, so it could be between 1 through 9. What about this guy? It'll be 0 or 2 through 9, and so on, right?
Mhm.
And so okay. All right. So that's the plan there. So now what we do is that so in this particular scenario, right? The mathematical formula essentially is that it is n factorial divided by n minus r factorial and r factorial. That's the formula for this NPR and for this. So in that scenario that we had, no, sorry, I missed that. It's actually just r factorial, not the other one. So in the case, in the first case where you had in the scenario where you actually had n factorial divided by n minus r factorial, in that case r was, you picked everything, right?
Mhm.
So which means that it will essentially be that you are the final answer is n factorial is the example. So n factorial is the answer for permutation. So how would it go about generating this in code? Anybody has any questions on what permutation is before we move on?
Vivek, what I'm not clear is what is R here?
R is the length of the substring that you want. So you could have all the letters of the alphabet, like so 26, that will be n, and then R would be like, let's say you want like like of length 3, so which means like ABC will be an option, ABD will be an option, and so on, right? The final output need not be the same size as the space that you're looking at. So in the first example that Pamela originally talked, it is 1, 2, 3 were the symbols, and we wanted an output of 3. In that case, R is also 3, N is also 3.
Can I try?
Yeah, go ahead.
So you basically start with any letter, like I'm just taking your example, like A. Let's take A, and you want to fill like so R is, let's say now 3, because you said ABC, it's R is 3. Okay. So you start with letter A and you want to fill 2 more spots, correct? So then you choose the next letter possible, which is like B, and now you have 1 more spot to fill. So you essentially build a tree-like structure and start from the first letter possible, and then go on and choose the next letter from the remaining pool of available letters, and keep going on till you exhausted all the R spots. And once you're done, you would backtrack and come to a position where you had diverged, and then like ABD, like ABC, once it's done, you come back to B, and then go to the next combination, next permutation, which is like B and D. So then you get ABD. Am I making sense?
Is there anyone with a question for Pramod?
On top of that, we found a tool that we knew resolved exactly what we needed. We went through every column, every row, and said, okay, does it solve this problem? Yes. Does it solve this problem? Yes. And that made it really, really easy to like this particular library. And on top of that, we communicated that change really well. We had a React-like group on Fabricator that would get pinged every.
Okay, so that was not a conversation for us.
Sometime, yeah, I was thinking that he was giving feedback to me. Okay.
That's what I thought, but unfortunately, I apologize for that.
Okay, no. Okay.
Go ahead. Anybody else with concerns about what Pramod's approach was? Does it make sense? So let me ask an open-ended. Okay, so Pramod, Nanya was asking you to repeat. Can you repeat your algorithm? Just break it down. Use Etherpad for narration.
Definitely.
Go to like line 45 or something, and then start typing.
Yeah. So what I was saying is what I'll just try to repeat what I said. So it's okay. Just a second. I don't have the link to the Etherpad.
It's the same link as before, so it's public Etherpad as skills. Let me just paste it on the chat.
Yeah, thanks. Yeah, I think I have it.
That's okay. I pasted it on the chat, so go for it.
So what I was saying is you have 26 letters. So I'm gonna type at line 46. So you have 26 letters, A to Z, and let's say you have to fill 3 spots, right? So you have like 26 options for the first spot, 25 options for the next spot, and 24 options for the last spot. So how did I think about this? So when, let's say the first spot was A, and then you went about saying, okay, I'm gonna choose AB or then AC, and then if I choose B, I'm gonna choose C as the third element, and D, and so on and so forth. So when you traverse this tree of you would choose like ABC. If you go from the root to any of the leaves, you would basically get one permutation, one of the several permutations. And how did I come back after I finished? We'll see. I understood that I've exhausted all the 3 spots, so I will come back to B and now start exploring. The other letters. This is the question. What I'm trying to answer here is, if you have 26 letters, I want all the 3 permutations of all these 26 letters. So I can start with A, or I could have started with B, all the way to Z as the first letter. And if I start with A, then I understand. Okay, I can go with B, C, D, all the way to Z, and so on and so forth. So
got it. It makes sense. I think I understand.
Very naive, naive
but it's like it will be a big tree. You're actually specking out the full tree, and then your tree actually has essentially depth of 3.
3, yes.
And at the first level you have 26 elements. At the second level you have 25 elements under each of the 26 ones, and then under that you have 24 under each of that. So far so good. Like everything makes sense. How would you deal with a scenario where you have duplicates in your letter space?
Okay.
Like if I give you like AA, BB, CC as your input space, and I want you to make 2-letter combinations.
Okay.
Right? How do you do that?
So to enumerate some of the 2-letter combinations, is AA a valid combination, or is AB?
AB is a valid combination. AA is a valid combination. BA is a valid combination.
Okay. Right. So what I would basically try to do is I should just ensure that I should probably hash the duplicate values somewhere and check, okay, if I've already addressed if I've already included a permutation involving a duplicate member like A, B, I should never come back to to just give you some context, I'll just name this as A1 and A2. Okay, so
correct.
Now this is A1B. My target is to ensure that I don't reproduce A2B again. Correct?
Correct.
One way to think is actually to treat A1 and A2 as 2 different things and then prune later on. But that's like that's essentially like that takes more time. But what we can do is we can smartly hash the duplicate members, and once you already generated A1B or let's say AB first time, I ensure that next time I go even start A2, I don't generate B at all after that.
Okay.
That's one way of.
So for permutations, order is important. We're just walking through permutations first, and then we'll do combinations after this. So let's continue with permutations.
Okay.
And how would you? So in general, right, for such interview questions, you do not want to go into a situation where you say that I'll put it in a hash set, and I will or a hash set or a hash map or some kind of a unique check and then I will ignore all the duplicates, right? That's actually generally a terrible idea. I mean, it works, it gets the job done, but it doesn't score you any points in interview.
Okay.
So you are looking at finding the right way to do it without having to without having to actually use an external unique or deduping scenario. So how would you do that?
Okay.
I have a question. So, is it necessary that the AA should stay together?
No, it's not necessary.
Okay.
I mean, if I had a scenario where you were supposed to do 3 characters, right? ABA is fine.
Okay.
But as he was saying, like I'm going to just make one of them lower A and one of them capital A, right? So ABA is identical to ABA, right? If it had been C, you would have had ABC and CBA or something like that. Those are 2 different ones. But in this case, since they're duplicates, you would be generating them. If you use the same n factorial divided by n minus r factorial kind of a scenario, then you would be generating them, and that's what we want to avoid.
Okay.
So how would we do that?
Vivek, I had a question. Why is it the same here? They are not.
There are 2 A's.
I mean,
So ABA is the same as ABA, right?
Yep.
Oh yeah. That is the same.
That's
But
all I
I
was
thought
saying. I'm enumerating it to as an example. Pramod was using A1 and A2 as examples. I was just using uppercase and lowercase, just to say that one is the first token is the third token, and the third token is the first token. That's all.
Oh,
Right?
okay. So yeah, I got it.
Well, that's good. So how would you do that? Can you have a nested loop, nested for loop? How would you use a nested for loop to generate this?
A nested for loop to generate which one?
For the permutations. Nanya, if you do have your microphone on, or if you're able to speak, you should be able to address the folks. Yeah, I have unmuted you. Go on.
Okay. What I was thinking was, since we're given this array of characters, so A, A, B, B, C, C. So for each character, you would print out for each character you would print out the character from the outer loop and the character from the inner loop.
Okay.
So basically, if for example you have the first one which starts at the index will start at 0, but the inner loop would start from the next I plus 1. So basically,
yes,
you're going to be printing out.
But when you do that, it will not work for the duplicates cases, right? Because it will print ABA, and again it will print ABA later if you have 2 A's in your system.
Can't we?
Is it for 2-letter combinations or 3-letter? I thought it was 2.
Hi, can you hear me?
Yes, we can hear you.
Okay, so like, can't we hash like? Sorry, I just joined in. So can't we, like, before we start generating the permutations, can't we create a hash set and then remove duplicate characters in advance, and then go into this loop to generate permutations?
If you remove duplicates, then it will not give you the right answer, right? Because ABA is a valid 3 combination, or like if you look at 2, then AA is a valid combination. If you remove duplicates, you will not see it.
Oh, okay. I thought that we want like non-duplicate characters in there. Okay, now I get it.
Yeah. So the intention is actually to prevent duplicate permutations from showing up, not from duplicate characters to show up in the output. The duplicate characters are fine. So go ahead, Nanya. You had the point I was trying to make was that how would you make sure that you are you're not generating A, B twice because there are 2 A's in the file. Like once with the first A and once with the second A.
Like, what? It's a clarification question. Like, if we go with a recursive loop, right, we can only avoid duplicate at the topmost layer or the final layer, right? Because we need duplicates within the internal loop. For example, if I have like ABC or AAB, I want BAA.
So why don't you walk me through the duplicate solution, the recursive solution first?
So what I was thinking is, like, it is basically, for example, if I am in the index 0, right? I say I am at index 0. Now give me, and assuming my length is 3, right? The number of permutations I need is 3, and I am at index 0. I say, given the rest of the characters, now give me permutation of 2, and then I append myself to that.
So let me actually. I think we'll go back to the very first suggestion that was actually given, right? Let's go back to that one. And the way we wanted to do permutations was that you wanted to, what I would say is like pick, I'm on line 67 if you are on the Etherpad. So you want to pick the first character, right? And then you want to create a set character, okay? And then you want to basically generate a permutation of n minus. You've eliminated the thing and using the new set, right?
Correct.
And then essentially what you're doing is for each of this value you just like prepend the first character you picked. Will that not solve the problem? Not yet, not for the duplicates yet. But just
the first character will always be at the first index, right?
No, pick the first character as in you will go through making the first letter the first character, then second letter the second character, first character, and third letter the first character, and so on. So if you have like if you're given an alphabet of 26, right? Essentially, what you'll do is you will first pick A, okay, and then you will run. So essentially, I'm asking you to do permutation of 26, comma, let's say 5 is what you want to do. You want to get combination of that, and you're given a set which contains A all the way to Z, right? This is what you're given.
Right.
So what I'm doing is I'm picking the first letter. There are 26 ways I can pick the first letter.
Yes.
Okay. So then for the first letter, then I after this I run a permutation of 25 of size 4 using only letters B to Z.
Right. You exclude A.
I run a permutation of 25 characters of 4 using only letters A, C to Z, and so on, right? So far with me?
Yes.
Okay, and then you can do this recursively, right? If you do this recursively, I mean, in the sense that perm of 25, 4, how does that work? Essentially what you'll do is you'll take, so what I do in this case, right, I would actually prefix equals null is what I would pass on. In this case, I would pass on prefix equals A.
Right.
Okay.
Okay.
And as a next layer of iteration, what I'm doing is so essentially in this case it's prefix plus A. That's what I've done. So far, so if I did this, what is going to happen is that at the very first instance, you have passed a prefix of nothing, and you've said I've give you 26 characters, and of the 26 characters, A to Z, get me a permutation of 5. Right, and then what we do is we take the first one, and we fix the first letter, right, and then we put it inside the prefix, and we send it out and say now of the remaining 25, find 4, make permutation of 4, and get it. So at the end of the day, when we finish the whole process, when the termination condition for this recursion is when R is 0, right? That is how you can solve this. Now this will work for unique scenarios. How will it not? It will not work for duplicate cases, right? So the way it works for duplicate cases is that first thing you do for duplicate scenarios. So before I go into the duplicate scenario, is it clear in terms of how permutation works?
So it's a recursive. It's essentially a recursive approach that you're following. Right?
Correct. It is very similar to the trees thing you just mentioned. The tree is nothing but like a graphical representation of this recursive.
Correct.
process.
Correct.
So it is identical to what you said, except that you can't write a tree. I mean, you have to write code, right? And in code, you have to write a recursive function.
Yeah.
So if folks are not familiar with how to write recursive function for this, please take some time and go through this and deal with this. Write it down. You should be able to generate it. The same thing appears for in terms of recursive brackets and parentheses, and there's a lot of different ways in which people modify this question. But you need to know how to generate permutations of a given data set.
Okay.
NPR, you have to know how to do that. Okay.
One question, Vivek. What is the complexity of this this approach? Is it exponential?
You are actually generating the combinations, right? All of them.
Correct.
Correct. All permutations, right? You're generating all the permutations, and how many permutations are there?
So 26 P5.
Which is?
26. Yeah, 26 factorial. Right.
It is n factorial, but in this case, it's actually n factorial divided by n minus r factorial.
Correct.
So in this case, it's 26 times 25 times 24 times this, and given it's all numbers, it's constant time because these are all like small numbers.
Okay.
But if you were to kind of generalize the solution, then the time complexity is exactly n factorial divided by n minus r factorial.
Okay.
And space complexity is a lot more. It's a lot because of how we do it. There is a trick to do this in place.
Okay.
Okay, you can do this in place essentially. So instead of actually, so the way to do this in place is that instead of creating a set later, right, you just swap the location. So if you want to, when you're trying to generate for A, right,
okay,
you just say that my set now starts from second location to last location. Correct?
Yes.
When you're trying to solve for B, what you'll do is you'll actually swap B and A in the array.
Okay. Swap B and A. Okay.
And then you will say that my remaining array is basically A through Z, right, which is like 25 without the B.
Right.
And then so on. So essentially what you do is that you swap the letter that needs to go into the permutation at that particular location. It's not as complicated as it sounds, but you have to practice doing that as well to see how that works. In most cases, you don't need to do that for an interview. I mean, knowing how to generate the permutation is important first. If you're able to solve that.
I couldn't get the swap one actually.
Sure, Karthik. So the way it works for in-place sorting is that what in-place permutation is that you have locations. I'm just going to put the location numbers, right? So what you want to do is the way you want to generate this is that in the first permutation. Actually, let me use A, B, C, D, E, and so on. That is how the set comes to you as, right? And then what you're saying is that you want to use all the way from 1 through 26 to generate is what you've said at the output.
Yeah.
The next step is basically what you do is you keep A as is in the same place, and you go all the way B to Z, and all you're saying is that's permit from 2 to 26, which means you're not touching the first letter. Okay, this is a recursive call. It is identical to the recursive call in line number 80.
Yeah.
The line number 81, when you're about to do that, what you do is that you swap B and A, and then you do the recursive call which says like do the same thing from 2 to 26. It's not as complicated as it sounds. Just take it on a piece of paper, write it down to see how that works out. Okay.
Okay.
Now, now the way this works is for duplicates, right? Is that if you had, instead of it being A, B, C, D, E, F, right? Let's say that it was instead of 26 letters, all of them were double.
Okay.
So we had A, B, B, C, C, and so on, right? Okay. So there are 52 letters, correct?
Okay.
And you want to make permutations of 5. So the first one is you want to make prefix of A. You want to make 51, 4, and 1A is there, and so on, right? This is how it is. 80, line number 80 is clear?
Yes. Yes.
What is 81?
So you would basically.
It's the same, right? Because the second letter is also A.
So you understood it's a duplicate.
So you just ignore it, and it's not a very complicated step. If previously you handled A, then next time don't handle A. Just ignore it. Skip.
You're
81 is skipped.
Please sort it.
You have to sort it. That is correct. You have to sort it So you have to sort the data. So for permutation, the input data, if you sort it or don't sort it, that doesn't change the outcome, because you're only selecting from that and then you're actually arranging them, right?
Yeah.
Since it's arrangements, the order doesn't matter. So what you do is you sort it first, so that all the duplicate elements come right adjacent to each other. So when that happens, all you have to do is you just have to, first time you see a you use it. The next year you can just skip, right? If you had like 10 A's, right, you can skip all of them. You can use the first one, you can skip all the 9, and then after that you go prefix.
Within every recursive call we will have to sort it, right?
No, you don't have to, because once you have sorted it, right, after that you are only taking the remaining elements. You're only taking one element off, right? All the elements are supposed to be in sorted order.
But how do we take the element off?
In an array, if you delete one element from a sorted array, the array will remain sorted, correct?
No, but like in that case, when I come out of that loop or come out of the recursive call, I need to add that element back, right?
No. You are not adding that element back. You are creating a
copy of the. Okay.
You are using the original set which is sorted, and then you're only taking that one element out.
No, but for example, when I go to C, right, now I need the A back.
You don't need the A is already there in the original set. You start with set, the 52 set is there first, right?
Yes.
That contains everything.
Yes.
Now you create a 51 set with which doesn't contain one A.
I create a sort of a clone of a set. Okay.
Correct.
Okay.
I mean, why complicated? Why not just keep the original set around?
Yeah.
Then you create a 51 set with missing B. Then you create a 51 set with missing C, and so on, right?
Yeah, got it.
Simple. If you do this in place, it becomes a little bit more tricky.
Okay.
Because when you're doing this in place, right, then the problem is that when you're doing the swap, you have to do the swap in such a way that the everything on the right is also in sorted order. So swap will not work.
Okay.
Right, because if I take the first.
I have a question.
Go ahead.
Yeah. So why do you have to skip the second A?
Because good question. Because once I have created, like, the way I would look at it is that let me see if I can take an example and explain, right? So if I have A, B, B, C, C as example, I'm on line 78, then and I want to generate for simplicity's sake, I want to generate permutations of 2. Okay. So I would basically that is A plus permutations of A, B, B, C, C of 1, right? That's what it is. Then it is, so that gives me all the combinations. It actually gives me A, it gives me A, B, okay?
Yeah.
And then it'll again give me A, B, which is duplicate.
Correct.
It'll give me AC and then AC, right? That's wrong. So that's why we want to skip the second B.
Correct.
Oh, okay.
A similar note, again, at the next step, I don't want to do this, right? I don't want to do again a plus perm of A, B, B, C, C, comma 1 is wrong, right? This set will be identical to the set that you have generated before, so you can completely skip this. So rather, what we want to do is we want to do B plus perm of A, B, C, C, comma 1. That's what we want to do. Since it's 1, it's a little weird, but if you have like a larger number, right, you will notice why this algorithm actually preserves the sanctity. So this, if it had been, if you were trying to not generate perms of 2, but you're trying to generate perms of 3, then this algorithm will actually generate a BAA as well.
But if the second A was maybe like a small A.
If it was a completely independent character, then it is an independent character. Is in the output permutation, do you want to treat small a and big A as different letters? If yes, then they are completely independent. I mean, the fact that it's a is irrelevant. I mean, it's just 2 different letters. If the case is if it's case insensitive, then you have to do the same thing, right? So when I say duplicate, I'm using it in that way.
Okay. Oh, makes sense.
All right.
So, I had a question. So is it so we're basically sorting it just to make sure that we are not taking duplicate elements. So at every step of the recursion, instead of sorting, can't we just keep a track that we have encountered A or no. Maybe.
Correct. That will also work. That will also work. You're right. So essentially, the idea of it's we don't want to really sort it. What we want to do is we want to make the duplicates come together. If the duplicates come together, then you don't need any auxiliary data structure, right? You can. I have already handled X. The next 5 X's, I can just leave it. It's very easy. Right. Otherwise, what I have to do is I have to maintain like a hash set or something that says here is the letters I have handled already, and then you can keep pumping into the hash set. Then you don't have to do any sorting whatsoever.
Okay. So it's either sorting with n log n or auxiliary with on and checking at O of 1. So it's basically the space time. Okay.
And in this case, the leading function is the n factorial divided by n minus r factorial. So either won't work. So it's just easier to do it that way. Code-wise, it's also simpler. And memory is less like it's more optimal for memory to do it this way because you are not creating.
Why is sorting coming in picture actually? Should we not just remove the duplicate and get all the unique elements in the beginning?
How will you generate a AA as a 2 permutation?
I see. Okay, still it's a valid permutation. That's what you're saying.
It is. Yes, it is.
So is hi Vivek, this is Devi. So is AC and AC valid? Like
no, they are not. So the example in 81 is that we need to actually eliminate this AB and this AC should not happen, and that won't happen because we are eliminating. We won't be considering duplicates that come adjacent to each other, right? The skip will actually skip these things as well.
Hi Vivek, this is Gopal.
Hey, Gopal.
What is the termination condition of this permutation function which you are calling recursively?
Termination condition will be if R is 0, right?
Okay.
Then you return a null string.
Okay.
Correct?
You keep subtracting from R as you go through, right?
You are reducing R, right? If you look at the example, in 85, I'm saying 52, 5. 5 is R.
Correct, yeah.
Then I reduce R to 4, right? So that means R is now 4. When I call further down, it will be R will be 3. When I call further down, R will be 2. Then 1, and then 0. And that 0 will essentially become, I mean, in that case, I can just return the prefix as is without doing anything to it.
Yeah, because the prefix is the permutation.
That is correct. Right. It's basically saying that if I give you a particular arrangement of some number of letters, like 5 letters, can you add 0 letters to make another permutation? The answer is yes. Here's the answer. Whatever you gave me is the answer. So that's how I look at it. Right? Great question.
I had a question. So generally in these kind of questions, is there a difference between printing in like the base case and versus returning all the way back up to the initial frame? Because returning is slightly more, I mean, you have to return from each frame and then, I mean, there's a little bit more code that requires to be done, whereas in printing in the base case, it's simpler. So is there something specific that's asked in terms of implementation?
Permutation in of itself, I don't think is asked as a separate interview question. I mean, I think it will be fairly dumb to just say print all permutations of something. It's usually like hidden inside an interview question which involves creation of permutation. So in those cases, if you're able to get away with generating the permutations and then at the point of like, the end of the recursion, if you're able to call the payload function, whatever you're trying to do with it, then you're fine, right? You don't have to do anything after that.
Okay.
But if you don't do that, and if you need to generate, like, the output is usually interview question will be like, give me print all combinations. Then you can print anywhere you want. That's fine. If the interviewer specifically says return, then you would say, you know what, I'm going to just return an array list or something. Do not put it in a global variable. That's what I would recommend. Like, don't try to retrofit this by having like a global hash map or an array list. And then trying to, instead of print, putting it that is something please avoid, because that generally represents that tells me that you are super lazy, and the next time you have a problem in code like that, you're going to go create a global variable, and that's going to be a big headache for me much later. So you probably know how many times lazy programming, like now has caused like tons and tons of pain much later. So you don't want to even go near that. If they ask you to return, then you have to do all the mathematics behind returning, like all the heavy lifting and whatnot. Return the right variables and clone it, copy it, whole bunch of stuff. It's not that pretty, but it's not super ugly as well.
Yeah, I wrote a version where I cloned it and then added it to an array list, which I passed down the stack.
So we are going much slower than.
Is there any dynamic programming solution to this? Because at some point it becomes like duplicate work, right?
Not that I know of. If there's anyone who knows a dynamic programming solution to this, it will be interesting, because I think the permutation as such, right, in terms of how the formula is it just lends itself to repetitive calculations, and you have to go through the process of doing it. So the in-place swapping based solution, I think if you look at CoderPad, Vamshi has typed a solution for the one without duplicates. That's like the one that we discussed. And with duplicates, there's a similar solution you can write, but those things are the ones that you can. That's kind of closest you can get to dynamic programming solution. I mean, it's the most optimal, doesn't use extra memory, and uses as little space as you can. Right? So, just a quick time check. We are actually going a little slower, and I think it's appropriate because this is a fundamental concept. I wanted to make sure that we all get it and get it right. The more we should practice this, all right? And I'll spend a considerable amount of time on the subsequent ones, the combination and the combination with replacements, so that we can make sure that we're clear in this one. And if we run out of time, then we can just take the remaining questions and do it next week. So go ahead.
In the first permutation, right? You said A plus perm of A, B, B, C, C, comma 1.
Mm-hmm.
How do you avoid the second AB and the second AC? You just marked it as X, right, for the first time?
Brilliant question. So let's do perm of A, B, B, C, C, comma 1. Okay, what is that? What's that?
It's just A, B.
And I have to pass A as a prefix to it, right?
Okay, so it's AA.
So it is it is actually perm of prefix is AA, comma BBCC, comma 0, right?
Right.
What's the next step? Perm of prefix is what?
Prefix
AB.
BC ABCC 0.
Correct. What's the third step?
Prefix of again AB, right?
Ignore.
AB should be ignored, right?
This is how I ignore it.
Okay.
Right?
Okay, got it.
Just like how you are ignoring I'm just going to do ... here. Just like how you are in line number 90 in the first scenario, you are skipping this.
Right.
Because A is duplicate.
Correct. Okay.
In the same way, underneath, when it's time to take B for the second time, you know that you've already handled B this time. In this loop itself, right? You've handled B, so you can skip it. Easy, right? Awesome. Any questions or any concerns on permutation and permutation with duplicates?
Hi, Vivek. I have a point here, so I'm not sure if that will work, but I just wanted your opinion.
Who's speaking?
Yeah, this is Achint here.
Hey, Achint.
Yeah, hi. So can we do it as a two-pass solution, like first taking the AA, BB, CC, and then reducing the set to A, B, C to Z, and then like the first solution?
No, can you repeat your solution?
Yeah. I was saying that can we do it as a two-pass solution, like in the first pass, taking the combinations of AA, BB, CC, and then in the second pass, just reducing the whole set to 26 characters, like the first solution?
But that won't work, right? Because
it won't work. Okay.
Think of it. No, don't take my word for it. Think through this, right? So what you're trying to do in the first pass is that what did you do? You're trying to do. If you're only trying to calculate permutations of 2, right? That becomes
Oh
probably
yeah,
trivial.
that will be that
Right,
will be
but
only for 2. If it's
yeah.
more than 2, then yeah.
What
You're
if
right.
it's 3? Then how does it work?
Yeah. Okay. Yeah. Thanks. Yeah.
Got it. So I think we had a question about removing duplicates. How are we actually achieving the removal of duplicates is that if you have in the current pass, what you're trying to do in every, think of it as a recursion, right? The first level of recursion is fixing the first character. The second level of recursion is fixing the second character. The third level of recursion is fixing the third character, and so on. Right? So what you want to do is that if you have duplicates in the very first level of recursion, right? You are trying to fix the first character as A, and then you're trying to figure out all the other combinations. Then in the second loop of the iteration, you're trying to figure out what the first character will be. It should be B, and then you're trying to fix the recursion and so on. Now, if you have duplicates there, you know that you've already placed the first case as 1, right? First letter is A. You don't have to do it again, and that's why you skip it. So if you look at the example that we have here, line number 85, I fix the first character as A, and then I'm trying to generate all the other combinations. Then in the 90, I'm again, the second character I'm picking up from my set is also A, which I don't need to do. That's duplicate. So I can completely ignore this entire permutation. It's not required. Then rather I just start with keeping the first character as B and try to find A, B, C, C, and carry on. See if I can find recursion of that. Does that make sense? I mean, try it out. Take a piece of paper and pen. Try to do this, and I will be uploading this video soon. If you have the opportunity to go back and watch through this, I think it's fairly intuitive. Once you understand the fundamental concept behind it, it's intuitive. The thing that throws people off is the duplicates. How will you deal with duplicates? And in almost all scenarios and interviews, or even otherwise, when someone actually says there are duplicates, how do I deal with it? Please do not suggest that you will put everything in a set and the output is unique. Right? That is not an answer. I mean, it's like, yes, it's a cop-out. You can do that in certain scenarios and it might be okay, but more often than not, the duplicates are actually super expensive. Imagine if I were to actually ask you, like, what are the unique binary sequences that are possible when I have, like, thousands of binary or something like that. It's hard. I mean, you'd be creating so many duplicates and it just doesn't work.
Sorting each and every input, is that the, like, in case of unique binary sequences, right? Is sorting the right solution in that case?
Binary is a different example. I'm just reading the one of the comments was given is that PS, you should publicly post your comments so that everybody can read that as well, and not just do it privately. But so the question is, I'm just going to see if I can paste the comment. Oh. No, I'm not able to copy the comment for some reason. When perm of A, A, B, B, C, C, you parse A, and then skip the recursive part of A, B, B, C, C. Which line is it? I'm not able to do it. And can you please get on the audio bridge? Okay.
Hello?
Yeah, go ahead.
Oh, hi. Sorry, I'm just new, so I just don't want to. I'm just checking out the interface. I don't know how to publicly put comments.
That's okay. That's fine. It's just easier that way because everybody is also trying to learn at the same time, right? So go ahead. What is your question?
I was just like trying to recollect how you were like able to generate AA and then skip the part where you include the second A in the permutation loop.
So this example, unfortunately, since I'm only generating 2 characters, right, like line 85 through this, it becomes a little weird because there's no third thing to generate. But so what I've done is in 85, you're looking at the coder pad too, right? The ether pad. So line 85, I take the first A. What is the remaining string without A? That's like 1A, 2B, and 2C, right? So now what I need to do is I need to generate one letter from the subsequent things, correct? In order for me to do that, what I'll do is I'll actually create the first order, which is AA. Like I'm just taking the first letter of the set that I have, which is this set, which is the ABBCC set. The first A is already gone. Okay, so I just add the second A to the first A and I got AA. Now I have BBCC as the remaining set, and I need to try to recursively generate permutations with 0 size from that. That's a little weird, which means essentially the answer is just the prefix itself.
Yeah.
In the third step, I would take the second element of the set, which is essentially the first B, and I will try to I'll create a prefix of AB, and what remaining elements of the set is A, B, C, C. And I need to generate a combination of like 0 length from that, a permutation of 0 length from that. That's fine. And then the fourth step would be, again, I need to do that. And in this case, since B, I have already handled B as a second character, I don't have to handle this anymore, and I can just go and continue with C. Right?
Okay.
That's it. And then again, I will try to do the same thing for the fourth character, but since it's already handled in line 89, I don't have to do it in line 90.
So let's say you have like n number of B's, so
I'll skip all of them.
Skip all of them. So is it like, how about like I just remove all the duplicates in the first place and create the square of that element, include it in the permutation, and is it like, will that generate the same permutation?
It won't, and the reason for that is, like, let me actually take this one step further, right? Let's say that you wanted to generate combinations of 3. Okay, your goal was to actually generate where the prefix is blank. AA, BB, CC was the original question, and you are asked to generate this size 3, which means that you'll do this and say that of the set which contains 5 letters, 1A, 2B, 2C, I need to generate combination of 2, permutation of 2, right?
Yeah.
Which means that I need to generate this in combination of 1. Correct? Now, in this case, further inside, it is PFX is ABA, comma, BCC, comma 1, comma 0. Correct?
Yeah.
So in your scenario, when you do the squares and things like that, you will not be able to get to a ABA kind of a situation.
And also the other problem will be, there is also one more problem in your
One second, Santosh. Before that, let me just make sure Sundar got this.
Yeah, I got this. Yeah.
Okay, so I mean, this is something that it's a very common. So one of the problems with how we learn things is that we try to kind of do some kind of a pattern matching and try to solve it. So the scenario that I believe somebody else brought this up as well, saying why can't I just generate all doubles? So I'll generate A, B, B, C, C, D, D, E separately, and then I can just run single combinations of single permutations of all the unique letters, and that will work. But that will only work for NP2.
Yeah.
The moment it's NP3, it will fail. I mean, it's what you're recommending is actually a different version of the same problem. All right?
Vivek, I had a question. This is Supriya.
Supriya, just 1 second. Santosh had something before that, so let's go with that and we'll come back to you.
Yeah, the other problem in doing the square is basically it might happen that some element might not appear twice. So consider that your original set had A, B, B, C, C. That's it, and you are supposed to create permutations. In that case, you don't have another A, and if you square, you might end up creating element which may not exist.
Fantastic. That is the problem with all these tricky solutions, or like, clever solutions suffer from a lot of these edge cases. So if you don't have, if every character appears exactly twice, then this algorithm is easy. But if one of the characters is actually appearing only once, you are screwed because you will not be able to use it for anything, which makes total sense. Good point, Santosh. Go ahead, Supriya.
Vivek, what I was just...
Can you be a little louder, please?
Yeah, I was just trying to understand how the iteration actually, the recursion works in this case, in the sense that after the line 88, where you say that prefix AA and then you put BB, CC, comma 1, shouldn't the line 89 be the line 90 which you have indicated? As in the
yes, because I was just doing a level order at this point. So there's actually not just 90, there will be more lines here. It's not just that.
Right.
So you will have PFX of AAB, comma BCC, comma 1, comma 0.
0.
Right?
Right.
And then
which is your base case.
Yeah, which will be the same, and that will be excluded.
So, Vivek, when you say it is excluded, every time you will be comparing the existing prefix with the previous prefix that has already been computed?
Just one step above. Just one step above. Just the previous step.
Okay.
Because it's sorted, right?
Right.
So somebody else mentioned that instead of sorting, you can also create like a hash map, and in this current level only, right? I can create a hash map of all the prefixes and just make sure that I'm not reusing it for this level.
Okay.
Right, between lines 89, 90, 91, 92, 93, right? Those some of these lines which I've not written those yet, but those 5, 6 ones, I just have to make sure that I'm doing it only once. So I don't have to. If you sort it, then the dedupe is easy, right? In a sorted array, print only unique elements. The way you do it is you just keep comparing with the previous element. If it's not the same as the previous, then you print it. If it's the same as previous, you ignore and you continue, right? This is the same algorithm.
Right.
Okay. So the prefix is the same as the previous prefix, you won't call the permutation.
That is correct. It's actually fairly simple.
Yeah.
Okay, and if you guys, you should try writing the code out. I mean, permutation is one of such a fundamental coding algorithms, but it's not as simple as like you're just writing one for loop, right? It actually involves recursion, it involves prefix handling, substring, and you're creating a new set out of that. It's not as trivial, but at the same time, it is. I think Vamsi has code in the comments somewhere. I think it will work, but I'm yet to see what the specific thing is. All right. Any other questions on permutation? Great questions, folks. All right. Let's move on to the next one, which is essentially, now let's not do permutations. Let's do combinations. And what does that mean? Combination simply means that you either select or not select. It's essentially saying that I have a class of 50 people, and I want to create like a team of 4 people. So the order in which you choose them is not important. It's just that are you in the team or not in the team, and that's all is important, right? How would you do that?
So the combination considers that each element is unique and it's not a duplicate?
So let's start with unique, because the next question I'm going to say is that it's not unique. Okay, so you already know that. but let's assume it's all unique.
Okay.
It's people and teams, right? So it's obviously it's unique in this example.
So one way of considering combinations is like a binary representation. Either element, the number is a character is there or not. So the number of combinations is equal to the number of binary representation.
That's an interesting thought. I'll leave it aside for now and come back and come to that, because I think if I explain that, it's going to add more to the confusion than this. So let's actually go back and think about how to do this set, how to do the combinations. Any suggestions? Anything at all? I mean, how would you do it? Like if I ask you
assume like if it is a string of ABC, if you want to generate combinations, then generate first you can take a length of 1, the A, B, C, then you can have A, B, A, C, and then B, C, and A, B, C.
I didn't follow, Vamsi. Can you repeat?
Yeah, if you have a string of like ABC and you want to generate combinations for it.
So let's say you have string of A, B, C, D all the way up to Z, right? Let's say you have all the way up to Z. So you have the full thing. Now I want to generate all combinations of 3 letters. Okay? How would you do that? It's not fundamentally different from what we have seen so far, actually. So what you do is, who's the first member that you can pick in the set?
A.
Okay? Or B, or C, or D, and so on. Just like how we did for permutation, right? But in terms of combination, who's the second member I can pick? Anybody from B to Z, right?
Mm-hmm.
What about B? If I pick B as the first person, what can I pick?
Anyone before also, like the
A.
No, I can't pick A because I will not. I can't pick
you
A
picked
because
him already.
I could have the combination in which A and B both are picked has already been covered in line 119. So we don't want to do that. So it's only from C through Z. What about C?
D through Z.
D.
It is only D through Z. That's it. It's actually so. What you're doing is that when I pick a person like X, a person for the first location, I cannot pick anyone to the left of that person anymore. Okay. For permutation, since the ordering is important, I should be assuming that the second position can be A, C, B, D, E, F, G, and so on. But since ordering is not important, in this case it's only C through Z, and that's it. So far with me?
Mm-hmm.
Yeah.
Okay. So this is good. Now the code is actually very similar to the permutation code, right? Okay. In the permutation code, you had said it's A, comma, C through Z. In the combinations code, you will not have A. It's just C through Z. In the permutations code, it was A, B, A to B, comma, D to Z. That's how you had it. In this case, it's only D to Z. So you're not, the splicing is not required.
Okay.
That's it. Easy or hard?
What you're trying to just say is like in permutation you have to cover both cases of AB and BA, but in combinations you're just ignoring BA. I mean, you assume it's already
correct. And if you have two different permutations, right? How would you know that they are actually? How would you know that they represent the same combination? Like if I give you, to put it in other words, if I give you two different words, right? How do you know that they are anagrams of each other? How do you know they're anagrams of each other?
Store it.
They contain.
I sort the characters and then compare.
Yeah.
Right. So what does sorting the characters give you? Like tester and scepter are anagrams. What does that? How does that sorting? What does sorting give you?
It
gives you an order.
Gives the same order of
right.
The
okay.
characters.
So now, what we've done in this combination scenario is that when I have picked the first character as C, what can come to the right of C? Only letters that are greater than C, right?
Yeah. So the ordering is important. So once you pick it,
by definition, that will give you only one unique combination, correct?
Mm-hmm.
Mm-hmm.
That's about it. I mean, that's how, like slice it in whichever way you want, but that's how it works. Just different way of looking at it. I mean, permutation combinations are so basic and so simple that if you have to spend the time to learn it, once you learn that, it's actually pretty simple. Okay?
Well, just one question on anagrams. But anagrams are permutations, right? Permutations of letters.
That is correct. So the question I had was that how do you, the difference between combinations and permutations is that combinations, only one, anagrams will not actually exist in a combination because they'll all condense into one permutation. Correct?
Yeah.
And and that permutation is essentially one of the alphabetical sort of the system is also a permutation. What is that? P.
Essentially, like you can say, I think the combination is a subset of permutation.
It is, and the way we are actually generating it now is we are only generating that specific subset which is in ascending order, which is in sorted order string, and that is only there's only one way that can happen, right?
Yeah.
Okay.
So you're saying that the input order is important?
Not the input order is important. Actually, what I'm saying is that for combination, if you look at permutations and combinations, you will notice that multiple permutations will actually fold into one single element of a combination, right? And in this example, Pester, Scepter, and EEPRST are 3 different permutations using the same letters. But when it comes to combination, they're all the same combination. When it comes to combination, mathematically or programmatically, I am picking the 1 and 127, which happens to be the sorted order of the letters. Right? And that I have done by, that's the example I've given, right, which is very straightforward. Essentially, I've taken C, and then anything to the right, only thing that is greater or equal to C should come on the right. Why did I say equals?
Duplicates.
When there are duplicates. Precisely. When there are duplicates, it's actually not very hard. If I had 2 A's, right, or 3 A's, essentially it will be A followed by 2A and B to Z is what I'll do. And then the second scenario is also the same thing, so I can ignore it. The third scenario is also the same thing, so I can ignore it. The fourth scenario is B followed by C all the way to Z. That's it. It's actually not super hard.
So for duplicates, for combination, I can actually remove the duplicates and then...
No, you can't remove the duplicates still. Because, well, this is subject to the question. In terms of combination, right? There are the way do you want duplicates in the final output or not is actually an important question. If you want the duplicates in the final output, then you have to use the algorithm that I mentioned. If you do not want duplicates in the final question, then the answer is very simple. You just eliminate all the duplicates up front and you can just go ahead with it. Like eliminate all the duplicate characters before you even start, and then you can just solve it. That will work. So it's a matter of do you want the duplicates in the final output or not? And that will be a question I'll ask the interviewer. By default, the assumption is that you would want the duplicates in the final question. So even if I have a combination of like AAB, right, and a combination of 2 letters with AAB is AA and AB, and that's it. Does that make sense?
So can you like do the combination, for example, in this example,
so let's go on.
Write the output with duplicates and without duplicates?
Sure. So 135, please. Line 135. If I have the input set as AABC and I'm trying to find two combinations of this one, it is actually AA, AB, and AC, and that's it. Correct? If duplicates are not permitted in the output, then AA should not even exist.
Why BC is not a...
Did I miss that? Sorry. You're right. Thank you. Okay. So the possibilities AA, AB. In my head, I assumed there were 3 combinations, and I screwed up the duplicate one. But anyway, good catch. So these are the 4 combinations. If duplicates were to be eliminated and you don't want duplicates, right, then essentially what you can do is you can just pre-filter your input set to make it ABC and then generate the combinations out of that. And this will return AB.
What about the input is ABCA? In that case as well?
Doesn't matter. Sorted and removed, no? Same thing. If the input had been this, it doesn't matter, right? For permutation and combinations, the order of input tokens does not matter.
Okay.
Right?
Okay, so in this case, there will not be any combination of CA, right?
CA is not, CA combination is identical to AC.
Yeah, it's not there.
Okay.
AC is already there, right?
Okay.
In theory, you can. It's all about providing the number of combinations. And if you generate CA as a combination and not AC, that's also perfectly acceptable.
Oh, but because this is a permutation, in case of permutation, it will be AC and CA will be different.
AC and CA are different ones. In combinations, you have to have one but not the other, and you can provide either. The way I am choosing to provide in my algorithm is that the final output will be in sorted order. Every letter will be sorted.
Okay.
So CA is not valid because it's not sorted. AC is valid because it is sorted. Okay. Sweet. Are we good here? I think just looking at the time, I think we'll end up going through this and the easy questions, and that's where we'll stop today. But it was good. We will cover the medium and hard question next week. So moving on to the third one is permutation with replacement. What does permutation with replacement mean? That you can reuse the symbols. You don't have to consume. So if I have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and I'm generating permutations of 3 with replacement, it is actually all the numbers from 0, 0, 0 to 9, 9, 9.
Okay.
Easy, right?
You're putting them back to the pool. It's like even if you've taken one of the characters. Right?
Correct. If it's used once, you can continue using it. So you will have 0, 0, 0 as a valid. So permutation without replacement, when you say permutation, by default it is assumed that it is without replacement.
Okay.
Okay, but then you have permutations with replacement, which is essentially like a variation where just because you have used it once does not mean you cannot use it again. You can continue to use it. Okay.
Is it just like an extension of duplicates that we did earlier?
Is it?
Is it just like an extension of no?
No. Is it Achint? I understood the question. Sorry.
Okay. So I was saying that is it just like an extension of the duplicates we did earlier? So instead of duplicates, it's like a triplet.
This is more like you don't try to, if you select a character or an element, you don't remove it when you pass it. Like for example, in the regular permutation, you say A, B, C, and you select A, you pass BC for the next recursion. But here, I think you'll pass ABC.
Correct.
So think of it. So how many combinations did you create now? How many permutations did you create with replacement for three sequence of 3, length of 3, and using 10 symbols?
That would be 10p3, right? That's
not
standard.
Not
Sorry.
P. Oh, 10 power 3.
10
right?
N power 3. N power R.
So it's actually n with replacement is n power r.
Okay.
And how does that work? Is that you just essentially what you have to do is you have to generate permutations with replacement, fix the first letter first, and then generate the r minus 1 tokens after that. Okay?
Yeah, I think I'll look at it more later, yeah.
Generate the first token, okay, as a prefix, and generate with replacement r minus 1 subsequently, and that's it. It's similar to the things that we've done, like permutation, combination, permutation with replacement. The code looks very similar, but it's just that there's significant difference in like the termination condition and the propagation condition. Okay. Okay. So this is neat. So how do you deal duplicates in this?
So do you want you have to do you have to ask is it with duplicates or without duplicates of the interviewer, or it is assumed that you have to eliminate duplicates and then it's the same technique as above, like if 0 0 and you have selected 0 and just the next 0 it won't select because it's the previous same as the previous one.
But here the
Okay.
duplicates.
So hang on, Pramod. I think I like the way you've actually you've phrased your question. So in this case, I would not ask the interviewer is duplicates permitted in the output or not, because by definition, given that this is permutation with replacement, output is expected to contain duplicates, right? It's permutation with
But if the
replacement.
input itself has duplicates, it was going to have more duplicates in the output, right? And
Why? How does it make a difference? How do you know it's the first zero or the second zero?
It doesn't make any difference. So basically, on your input set, you're choosing multiples. So basically, you ignore any duplicates because you've already generated that case of the previous copy.
No, you just have to take the samples, the original set, and just make it unique.
Mm-hmm.
And that's about it, right? I mean, the fact that for replacement, there is no scarcity. You can use infinite copies of the first A. So the fact that there are 3 A's or 4 A's or 10 A's is irrelevant. So you just eliminate all the duplicates from the first set, like make it unique, and then you can apply your permutation with replacement algorithm on the final output, and that just works. Okay.
Yeah, that's actually what I was saying, but with other words.
Fair enough, and that's something for folks to think about. And if you have not thought about this in terms of, like, if you have not spent the time thinking about how these things work, it's very easy to get tripped up. And the choice of words that we use when you're asking questions or clarifying questions here might actually inadvertently reveal like how you're thinking about it. Supriya, you were saying something when I interrupted you. Go ahead.
Oh, sorry. I guess I was trying to say the same thing. I was thinking that I'll be answering, but I'm not sure. I was trying to say that when you say it is n power r, the base n in this case will become different, right? You are assuming that n is basically a set of n unique symbols. So when you have a duplicate in that, it won't be n unique symbols. It will probably be n minus 1 unique symbols or whatever.
It will be n prime. It's like it's a smaller m or n prime or n dash or something. It's like a different number which is smaller than n, which represents the unique sets. Totally, absolutely.
Correct.
That's what I was just trying to say. So.
That's a good point, I think. Yeah.
Okay, fantastic. Okay, so this is pretty much it in terms of permutations, combinations,
so,
and.
Can you talk about the termination condition? How is it different from the rest of the permutation with replacement, without replacement?
It's R0. That's it. Right, the same termination condition, because you won't run out of. You could. The only other challenge here is that what if in all of these cases, right, R cannot be greater than n. R has to be less than n, or equal at best, right?
Mm-hmm. Yeah.
So here also that's the same. I think the same problem. Here actually R can be greater than n. It doesn't have to be the same.
Correct.
Because you're doing replacements, right? So there's infinite possibility. So essentially, till R runs out to 0 is what you need.
Okay.
Like so far, right, in permutation, combination, regular permutation, combination, R cannot be more than n. It doesn't make sense. Like you cannot generate a permutation with more people than you already have.
Yeah.
Right, but in this case with duplicate with token replacement, since you have infinite copies of the letters, it's you should be able to generate those. So the termination condition is when R runs out to 0, because you are generating the first token and then you're generating replacements with R minus 1. When you're fixing the second one, the replacement is R minus 2 at that point, and so on. As you go down the depth of the recursion, at some point you will run out of R, like R will become 0, at which case you're done. Make sense?
Okay. Yeah.
Awesome. So now let's apply the newfound logic that we have, pieces that we have. I think we just talked about the first one, but let's go through it one more time. The easy question number 1 is, given 2 strings, can you validate if they're rearrangements of each other without sorting?
Anagrams?
Yeah, there is anagrams, but the solution that we discussed was you can sort them and compare, right? Let's say you can't sort them. The strings are immutable.
Then obviously you will have to maintain a count of all the characters, and then compare if they are the same for both strings. We can take the first string, maintain the count for each character that is there in the string. Then while going through the second string, we maintain a count for each character. Like we see the character is there in, we can maintain a map of the characters in the first string and check if the second, in the second. No?
Yep, you're able to hear you. Go ahead.
Yeah, so in the second string we can see if each character is there in the hash map. Like if it's not there, it means that that particular
they're not anagrams.
Yeah, it's not an anagram.
So if every one of them matches, it's an anagram. So that's a pretty decent solution. It's an alternate solution to using sorting versus using a hash map, or you're doing a hash map, not a set, because you want to count the occurrences as well, right?
Right.
Sorry, I think hash map won't work, right? Like, for example, if it's HELLO, hello, and HELO.
Yeah, the hash map, you need a hash map, not a hash set. Hash map actually will store the count in the second parameter. So it will be, L will have a value of 2 in one case, and L will have the value of 1 in the other case. So that's why hash map will work.
Got it.
Hash set will not work because
you can have multiples.
Because you could have multiple, and you would actually be attributing the same L to both the L's in the other case. I know people have come back with saying, I'll also do the length check in addition to using a hash set. Is that okay?
No. No.
Why not?
For example, say A, B, C, D, and you can have like multiple of the same letter too. Like
the links are not the same. It's not.
No, that's what I'm saying. So can I use?
It can be A, for example, A, B, C, and then
let me rephrase my question, right? So essentially, what I'm saying is that in the case of hello and HELO, right? The hash sets are the same, but the lengths are different. So can I not just say that, hey, if the lengths are different, then they are different strings, and the length has to match, and the hash set has to be the same, and that's okay, is it not?
But like the different characters could be duplicated.
Yeah, it is not okay actually.
Absolutely. So I could have like 2 H's in ELO versus HELLO where the length works. So you would not believe how many times I've actually heard the solution in interviews. So they come back with a hash set approach, and then as Gopal mentioned, I actually counter them with like, hey dude, what you're saying is hello and HELO, it's going to fail, and then they go back and say, oh, that's easy, I'm just going to do like a length check. That works, right? It actually doesn't. So yes, Ram, to your point a minute ago, yes, rearrangement is essentially you can sort and compare. All right. So what if you didn't have space?
I guess the interviewer would be happy if you use the permutations, just checking if one string is a permutation of another string. Correct?
Yeah. How would you do that without extra space?
I think we discussed that, right?
Swapping.
Using the swap method.
No, string is immutable, and
okay,
no extra space.
We cannot even maintain a count of the characters. Nothing.
Oh, constant space. So you can maintain something, but you can't maintain count of characters, right? You can't maintain a hash map because the symbol set could be unbounded, so you can't do that. The length of the string is also fairly long, so you can't do that too.
So you can't do an L-square algorithm? Like
how would the n-square algorithm look like? That's what I'm looking at. It's not as easy as it sounds.
Yeah.
How about the taking an array of integers? So index position represents the character.
That is the extra space. That is similar to the hash map solution, except
so
that
you
you're
don't
using
even
a bit
want
vector.
to use.
You can't use an array.
Okay. So is it a comparing each character? Does it exist in another string? Like that's the n-square approach. Check right. Character by character whether it exists in another string and reverse the same thing. For the other string also, string 1, string 2. Compare string 1 characters with the string 2 and string 2 characters with the string 1.
Yeah, but how would you compare? How would you know that it's not going to be in the same location, right? So how do you know that it's there?
Just existing or not.
Then the problem is hello and hello.
Hello,
H-E-L-O
that concept. Okay.
Can we mutate the strings?
Oh, no. Immutable.
Can you sort the string?
Immutable. Who just spoke, by the way?
This is Naya.
Hey.
Hi. I was asking if you can sort, because if you sort them and then check if
If you can sort them, then you just do a literal string comparison. You're done, right? So no, you can't sort. No, yes, the strings are immutable.
Okay.
Interviewers can't be. The interviews are not very friendly. Go on. So I don't think there's a very good answer for this one, but essentially what I'll do is I'll take the first character of the first string, all right, and I will go through all the characters in the first string and count how many times that character appears in the first string. And then I'll go through the second string and I'll count how many times that character appears. If that matched, right, if there are 6 A's in the first string and 6 A's in the second string, it's okay. Now I take the second character and I'll actually count in the first string how many times it appears. If it's a B and there are 3 B's in the first string, that's fine. Go to the second string, search for that if there are 3 B's. So it's essentially the same thing as your hash map counting system, except that I'm actually doing a full pass of the string each time to get that value.
Okay, the cost is in the execution than the space.
Absolutely. No space, there's no extra space required, right? It's only constant space. I need 2 integers to represent the count of the current character in first string and count of the current character in second string. You don't even need 2. Actually, you can make do with 1 int. Basically, what you'll do is in the first string, you keep incrementing, in the second string, you keep decrementing. Ultimately, it should be 0.
So if the string was like A up to 100 times, so for each of those 100
you will check A 100 times. You don't know because there is no memory, so you have no way of knowing that you already have checked A before. It will check A every time, and if it succeeds for once, it will succeed every time. If it fails once, you don't have to move forward anyways. You are correct. That is a problem with the solution, but the answer works. But you cannot do anything smarter without memorizing anything, right?
Auxiliary, right.
Now, how hard was this solution? How hard? Like, why were we not able to think?
Because you said it's not you didn't use starting, so.
Okay, and Ram has another point. Ram is saying that the second string can have additional characters, so you have to probably repeat the algorithm with the second one. How do you deal with that? We can just check the length, can't we?
Mm-hmm.
Will that actually solve?
Follow your approach. Could you just repeat what you just said?
The approach is that I will go to the first character of the first string.
Okay.
I will count how many times that character appears in string 1. Okay. And then I will figure out if so it's the first character is A, and in the first string, let's say it appears 15 times. Then I go to the second string. I check how many times A appears, also 15 times. So that's good. Then I go to the second character, and then I go search. In the first string, it appears 6 times. Second string, it appears 6 times. So I'm good, right? And so on and so forth, and I'm good to go. Right?
But if there is a character in string 2 that is not there in string 1?
Correct. That will be a problem. Correct? So what I would do generally is that before you start the process, if I compare the length of the string, if the lengths of the strings are different, then they cannot be anagrams by definition. Correct?
Mm-hmm.
Okay.
Yeah.
So I could do that. Is that but is that adequate? It's necessary, but is it sufficient?
No, it's not sufficient.
Why is it not sufficient?
Because you could have equal number of equal length strings, but with totally different characters.
But if they do, then it will fail, right? If there are 17 H's, they have to all the 17 H's have to be in string 2. It will fail. The characters have to be there somehow, right?
Can you just repeat the question? I'm not following you.
Okay. If I have an arbitrary number of characters in string 1 and the same number of characters in string 2, number of characters matched, okay? Then when I do the counting, I have counted letter 1 and whatnot. The counts have also matched for all the letters of string 1. Is it not a sufficient condition?
Yeah, I think it is.
Okay, you have to match the length of the
Just
string.
you just have to match the length. Once you've just matched the total length of the strings, you're good to go. So Ram's point was that there are additional characters in second string. Do you have to check that as well? And my solution to that is that you can use the length, compare the lengths up front and deal with it. So that way you don't have to deal with the second one. But that's actually a good point. I did not think of it when I was looking at this the first time.
Okay.
Great. That's fantastic.
So that's the first. I think that should be the first step when you're checking for anagrams, right? So that's the easiest step to eliminate anagrams that are not of same length.
Absolutely.
You don't need to do any of the parsing.
Absolutely. All right, so I'm going to take like 2 extra minutes before I turn this down, and then we'll take the medium and hard questions. Next one is infer a symbol set. Is essentially saying that given an array of strings, find a symbol set that can be used to generate the strings. Like what letters are being used. Essentially, if I give you a book, tell me what letters are used.
Hash set and parse all the strings, looking up and adding any new characters.
That's it. It's essentially if you do a hash map and count, right? It's instead of hash map and count, just use a hash set.
Right. Yeah, because you're looking for the symbol set, so you don't need, So yeah, it's just hash set of characters. Go through the strings, and come up with a set of characters.
Yep.
That generate those.
Anybody with a different opinion, or anybody who needs more clarification on this? Getting a symbol set, the best way to do it is just to pipe everything into a hash set and you're good to go.
Yes.
Easy. Okay. Infer master string essentially is that given an array of strings, create the shortest master string such that all strings in the array are arrangements of it, as in like partial arrangements of it.
You mean they should be in a sequence, like?
The master string is just letters. It's more like symbol set.
Okay.
So is it a combination thing? I didn't get the question.
Permutation thing. It is a permutation thing. So essentially, if I were to say, like if I say dog was the word, right? Then then the string that you need to generate this out of is like D, G, and O. That's it. As long as you have the master string as D, G, O, you can generate dog out of it.
If I say the brown fox jumped over the lazy dog, your master string is all the entire alphabet set.
All the letter, not necessarily, because duplicates are also supposed to be handled. It's not just symbols. It's not replacements. It's permutations without replacements. So if I had like a goof as another word, then you need to, in addition to DGO, you need an additional O and an F, right?
You need an additional O and an F. Like dog and goof, you should have G, two O's and F and D. Right? That's what you're saying?
No, you shouldn't have D. You should have J.
So you're saying even if there are duplicates, they should be considered. Like, for example, goof, GOF. That's what you're saying.
Correct.
And yeah.
If I have fool, in this case, in addition to D, G, O, O, F, I just need the word letter L.
Okay.
If I need good, I don't need to add anything. D, G, O, O, F, L is fine.
Oh, okay. So I'm losing the example now. So how is it building up?
It is in line number 164 through 167. How it's building up is that you should, in addition to being able to generate the letter or the word on the left, you should also be able to generate every word above it.
So is it like hash map with a count and finally?
Does that make sense? PS, you had does that make sense? Like if I
so let's say like for example the first dog, it just goes dog and then it has only one occurrence of O, and the second sentence goof, it just finds that there are two occurrences of O and then it has to include that O also in the right side.
Yeah, you need an O, an extra O and an extra F, right, to make that happen?
Okay, yeah. So you have to also have something like how do you generate this? Like is it enough that if you generate a hash set?
Hash set isn't going to do it. It's going to be a hash map with counts.
Yeah.
Okay.
Can we?
So
yeah, go
why
ahead.
don't we do this? Okay, I'm gonna given that we have 5 minutes over as well, and I think it's going to take a little longer for the solution. So let's park this, take this on as an exercise, and this will be the first question that we discuss next week when we come back. And what I'll do as always is that I'm going to spend the next like 15-20 minutes. So we'll hang around, we'll talk, we'll discuss other things, but not discuss the questions. All right?
Okay. Okay.
Right. Thank you, everyone. But go. Any concerns?
Nothing, Vivek. So this video you'll be posting within a week, or it'll how long?
Hopefully, the recording gets done immediately. I just have to I have to upload it to download and then process and upload. It just takes a little bit of a while. So yeah, within a week it should be there. Okay.
Okay.
All right. So that's the end of this session, and I'm gonna turn off the recording, and let's hang around for a conversation if you guys need any specific questions or queries answered.